Now certainly, the sample means that are in the extreme tails are low probability samples if the null hypothesis is true. That is, these are samples we wouldn't expect to get much of the time if that population was truly centered at 100. So, in the center, we have these high probability samples, ones we would expect to get if the population was centered really at 100. So what we're going to do is define how big that low probability region is. And remember, when we get a sample in those tails, when we get a sample really far from 100, that will be a sample that'll lead us to reject as a good explanation the null hypothesis. So in doing this, what we're defining is called an alpha level. That is the probability value that we use to define which sample outcomes are considered very unlikely if the null hypothesis is true. The reason for doing this again is that if we get a sample that's in one of those regions, one of the regions that are very extreme, that will be leading us to reject as reasonable the null hypothesis. So selecting an alpha level is a very important thing and something not taken lightly by statisticians. Now the most common alpha level you'll see is alpha of 0.05, which is akin to saying that the least likely 5% of samples, that is, in the extreme tails of that sampling distribution, would be evidence enough to reject the null hypothesis as reasonable. Now the value of 0.05, that specific value, doesn't have any special significance other than it was one Ronald Fisher thought was a reasonably unlikely occurrence, if the null hypothesis is true, for us to no longer believe the null hypothesis is reasonable. Now think about what this states. This states that the least likely 5% of sample means, that is 0.025 proportion in the lower tail and 0.025 proportion in the upper tail, are extreme enough to reject as reasonable the null hypothesis. Remember, the null hypothesis says that that sampling distribution is centered right at 100, right at the population mean after treatment if the null is true. So, if we get a very extreme sample, one that's in the least likely 5% of that distribution, we're claiming with an alpha of 0.05 that that is sufficient evidence for us to reject as reasonable the null hypothesis. What we've just drawn out is called the critical region of the sampling distribution. That is, the region of the sampling distribution that contains the sample outcomes that are considered very unlikely if the null hypothesis is true. And very unlikely here means unlikely enough, where if we get one sample, our single sample, in one of those critical regions, we're willing to reject as reasonable the null hypothesis. Now the margins between our high probability samples, if the null is true, and those low probability samples in the critical region is called a critical value. And one way we can decide if our sample is in the critical region is if it exceeds, in either direction, our critical value. Now finding these critical values won't be necessary for most of the hypothesis tests we do. But if we wanted to find the exact value that cut off 0.025 in the lower side and 0.025 in the upper side, we can use that distribution and probability calculator I showed before. Here, I've entered 0.05 in the input probability and calculate values section and selected outside probability value. What we can see is that on the low side, negative 1.96 cuts off the lower 0.025, and on the upper side, a value of positive 1.96 cuts off the upper 0.025. Now these values allow us to find the critical region or the critical values to compare our obtained sample statistic from. You might remember we calculated for our sample a z-score, and we could compare our z-score for a sample mean against these critical values. That will be one way to make a decision of whether our sample landed us in the critical region. We'll see later that it'll be more convenient for us to compare our sample p-value against our alpha value. But we'll come back to that when we evaluate our hypotheses. So in predicting and establishing evidence, we are specifically defining our alpha level. That is, the value or the probability that we consider to mean unlikely enough where we're willing to reject the null hypothesis as a reasonable explanation.